All right, more on circles. 10.2, let's first get the vocabulary down. We're going to be talking about a central angle, and this is an angle, it's inside of a circle. So it is an angle whose vertex is the center of the circle. Now, when we keep talking about circles, and as we talk about them, where the vertex of the angle is at is going to be very, very important. So the angles are going to differ in measures based off of where that vertex is. So just kind of keep that in mind. Where the vertex is in reference to the circle is going to be very important. All right, next is a minor arc. So arcs are basically the outer portion of the crust. It's kind of like the circumference. The arc is also like what I want you to think of like an arc is the crust of a pizza. All right, so all arcs are just the crust of the pizza. Now, a minor arc is just an arc that's going to be less than 180 degrees. Now, when we name arcs and we name a minor arc, we only use 2 letters. And so all minor arcs use 2 letters, and you're going to use, again, letters, whatever the letters may be, and then you're going to put a little arc over the top. So this is read as arc AB. Now, major arcs, again, still an arc is the crust, but major arcs are arcs that are more than 180. degrees. Now, major arcs, what we do is we use 3 letters. So kind of the same thing. Now we would say this is arc ABC and put the arc over the top. So again, that is read aloud as arc ABC. So knowing that a minor arc has 2 letters and a major arc is 3 letters, it's going to be important when you're asked to find the measure of the arcs. Now the semicircle is an arc that measures exactly 180. So this is an arc that equals 180 degrees, and we still would use 3 letters on this. So whatever 3 letters it may be, to name a semicircle, we use 3 letters. Now the measure of arcs. To find the measure of arcs, this is going to be the measure of the central angle. Now, when we kind of write the measure of the arc, we're going to do a little m, and then we'll put the arc name, and then we'll just put however many degrees it is. So again, that is read aloud as the measure of arc AB is 40 degrees. So you have to be able to read this notation and be able to say out loud or in your head, read it to yourself, this is the measure of arc AB. So that little m, you have to say measure before. This is just when you're naming the arc, so you don't put the m in front. Now the same thing, measure of a major arc, this is still going to be the measure of the central angle. It's just going to be greater than 180. And the same thing, you're going to use the little m, and you're going to use 3 letters. So the measure of major arcs. Congruent circles are circles with the same radius. And congruent arcs are arcs with the same measure. And they also, congruent arcs are going to share the same central angle. All right, now let's get into measuring arcs. So again, the measure of a minor arc is the measure of its central angle. So remember, we talked about Now let's see here. The expression as AB is the M as AB is read as the measure of arc AB. The measure of the entire circle is 360 degrees. So the measure of a semicircle is 180 degrees, like we just talked about. So here, this angle right here, ACB, that is actually the central angle of this circle, because you see how the vertex is on the center of the circle. So here, angle ACB is your central angle, and it equals 50 degrees. So therefore, arc AB, and so this is an arc, it's the crust. It's just the crust of the circle. Now, when you're doing any arc, you're going to have to follow the letters consecutively. So you're going to have to see how over here it says the measure of arc AB. We have to go in that order and start here at A and then say, okay, well, this is arc AB. The measure of an arc is the measure of the central angle. So since the angle equals 50 degrees, then that also means that the measure of arc AB is also going to equal 50 degrees. So if the vertex is on the center, it's the same exact measure. Now ADB, so that's again where I told you that the order of the letters is very important. You have to follow the order of the letters. So we start at A here, and then the next letter it tells us to hit, remember it's kind of like connecting the dots, is D. So we have to go all the way around, and we have to hit D, and then we have to go all the way to B. So it's asking how big is that arc? Well, the whole entire circle, remember, is 360 degrees, and the minor arc we're going to take away is 50, so what's left is 310 degrees for the measure of arc ADB. So let's look at example 1. Find the measure of each arc of circle C, where DF is the diameter. When they tell you this information, if you see that it's the diameter or they tell you it's the diameter, that is important because the diameter gives you a semicircle. And remember, semicircles are 180 degrees. So this information, being at a diameter, is kind of telling you to be on the look for. So look out for the 180 degrees. You're probably going to have to use it by adding or subtracting to find the measure of arcs. So the arc DE, right here. So the measure of the central angle is 117. So DE is a minor arc because it's less than 180. The minor arc is the same as the measure of the central angle. So the measure of angle DCE is 117 degrees. So that means the measure of arc DE is the same thing, 117. All right, arc DFE, since it's 3 letters, this is a major arc. So the measure of this arc is equal to 360 minus, so if we go DFE, we're going to take out that minor arc 117, so 360 minus 117 gives us 243 degrees. Now, if DF is the diameter, then so arc DEF, so if we get rid of this and we look at arc DEF, so again, you got to pay attention to the order of the letters. So if we go from D over to E and then to F, we're going all the way. We're going from D to F, and DF is the diameter. So DEF is the semicircle. So that means it is 180 degrees. I would like you to do checkpoint number 1 here and find the measure of arc RTS in the diagram, and then put your answer in the multiple choice question. Now the arc addition postulate. So this is, again, fancy things to just say, okay, if you have 2 little arcs, you can add them together to get one big arc. So if we look at arc ABC, well, if we go from A to B to C, you notice that there are 2 smaller arcs in there because we have an arc here, AB, and then you have an arc here, BC. So this one huge arc can be found by just adding the measure of the little arcs. So remember, two pieces are going to equal the whole thing. We did that before with segments and angles. So here we have an example 2. You join a new bank and divide your money several ways, as shown in the circle graph at the right. Find the indicated arc measure, so BD. From B, now watch, we have to go from B to D, and it's telling us here that BD is a minor arc. So you have to make sure, if it's only 2 letters, your answer must be less than 180. So if you travel here, B to D, you have to see there, B to D there is going to give you 200 degrees. So that's not the direction it wants you to go. It must be a minor arc. So you have to travel the short distance and go, all right, here is B. If I go this way, BA is 55 degrees, and if I keep going, that's 105 degrees. So 55 plus 105 will give you a grand total of 160 degrees for the measure of arc BD. And it's 2 letters. The answer is less than 180. Good, we can move on. BCD. So again, it's a major arc. So it wants an arc that's greater than 180 degrees. So there's 140. And there's 60. So this one is 140 plus 60, which gives you 200 degrees. And example 3, tell whether the given arcs are congruent and explain why or why not. So we want to say, all right, is BC congruent to DE? Well, yes, because their central angles are both 75 degrees. So those are congruent arcs. They have congruent central angles. So you can say that the measure of arc BC is congruent to the measure of arc DE. All right, example 3. All right, we just did that one. So yes, they are congruent because 75 is equal to 75. All right, in B, we have arc AB, which is right here. And we say, all right, what is the measure of the central angle? Well, it is 80 degrees. And if we look at arc CD, well, it's the same thing. This is 2 arcs that are going to share the same central angle. So this one's also 80 degrees. So this is, yes, they are congruent. And C is FG here and HJ. Well, you can see both of those arcs are opposite of 90-degree angles. So since they're both opposite a central angle that is 90 degrees, then yes, they are congruent. So all of these should be yeses.